Okay, everybody, I sent you an email over on Friday and I said I would make a video for you guys going through the review guide. So that's what I'm going to do right now. So hopefully you've checked your email and you got the link for the video and you can check the stuff out before the test tomorrow. Okay. So looking through this, there is quite a bit of stuff on the Chapter 2 test. So I'm going to kind of pinpoint some things that you should make sure that you know how to do. And the first page is pretty much, you need to know how to do all this stuff. Okay. And looking through this page by page, you're not going to have to write out the general forms like number 11 on page 3. I'm going to give those to you, okay? But you should know what the letters do for each of those, and you should know what a parent function is like those on the top, okay? The problems are going to look exactly like the ones down here on the bottom. You're going to see problems just like those ones right there. So it would be A, B, and C for 11, okay? So you'll have to graph the function, and then you will have to state what transformations are going on. Okay, and then there will be matrix stuff on there as well. Okay, so the problems are going to look very similar to the ones that are right on here on the matrix stuff on the back, the last page. Okay, they're going to be problems just like those. And for number 21, you're going to be solving a system, and I'll let you use either Cramer's rule or inverse matrices. Okay, so either one you'll need to do, but you will need to find the inverse of a matrix. Okay, it's going to look very similar. Okay, it'll be about the same length as the last test. So some of you guys it'll take 45 minutes to do. Some of you guys will take the whole section. Okay, so here we go. So find the range of the relation. So I didn't want both of them. I just said range. Okay, I think on the review guide I sent you that I did both of them. All right, but I just want the range. So remember the range of the y values. So write capital R with the curly bracket, and I'm looking for y values right there. Okay, so I have a repeat of the 3. Remember, we don't write repeats, but we do write these in numerical order. Okay, least to greatest. So my range would be a 3 and a 5, and then we want to determine if it's a function or not. So remember, if something is a function, it does not have any repeats in the domain. So if I'm looking in my domain here, I have a repeat right there of the -1s. Okay, so that means it's not a function, so I don't have to worry about anything else, because all the other characteristics apply to functions only. Okay, so looking at number 2, we want just the domain. Okay, so domain, I look at my domain, so that's x values. I got a 0, a 1, a 2, and that's all because there's only 3 points. Determine if it's a function. I don't see a repeat in the domain here that I wrote out, so yes, it is a function. And then remember, looking for the other pieces. You're more than likely not going to have a function that's just one-to-one unless it's a mapping situation. So it's going to be probably either onto or both. So if you're looking at it, you look for repeats in the range. If the range is repeating, which we are here, so we have a 0 there and there, that means that that's not one-to-one anymore because there's a repeat. Okay, so this one is going to be onto because of the repeat in the range. Okay. You will see a problem like number 3 where it's more of a real world example. Okay, so this is a mutual fund. And remember, I always say in class when we make our graphs, like which one is going to be the domain, which one is going to be the x values. Okay, the x values is always time. Those are always time. So I have a year, so this is going to be my x values. Percent return, those are going to be my y values. Okay, so we're just going to write the range of the relation. So it's not going to be the years because that's domain. It will be the percent return. Okay, so my range, we look at these points, find the first one. The smallest one right there is 20.0. Then we have 20.5, 20.9, and then 22.8. That's the range. And then same thing. Look and see if it's a function. Most of the time, real world examples are going to be functions because there's not going to be a repeating year with a different percent return. So yes, this is a function, and it is both one-to-one and onto because there are no repeats. Okay, so both because there's no repeats. Alright, so let's look at the ones down below. So these are examples of function notation. Remember, function notation is the f of x stuff like this. And when you see something like this, where it's f of 3, that means I just plug the 3 in for the x. I don't really worry about anything else. I'm just plugging the 3 in for where I have the x up here. Okay, so if there's more than one x, like in this one down here, I would plug the number in for all the x's that I see. So that -1 would get plugged into everything. Alright, so -3 out front, I plug the 3 in just like I have it there. -5, and I just run it through. So it's -9 minus 5, so you get -14. And remember, if you want to have a nice answer, you'd write f of 3 equals -14. So my function, when I plug in a 3, I get a -14. Okay? When you see something like this, you're doing the same thing. You're plugging this whole value in here. The 2x squared just gets plugged in for the 3, so it's going to look like this. Just like that. And then I just multiply from left to right and simplify as much as I can. So it's -6x squared minus 5. And that's it, because I cannot combine any like terms here. So that's it. Okay, let's look at a couple of the ones below. So when I plug in, I'll do A and B. Okay, because I want to show you what it looks like once when you plug in a negative and then the positive. Okay, so remember, if you have something squared, or if you're just plugging in a negative, I always said that it is beneficial for you to plug it into parentheses. So it would look like this. Okay, because then you can see what happens when you multiply negatives. Okay, so that right there is going to turn to a +1. And then this right here is like a -6 times a -1, so that'd be +6. And on the bottom, it's just -1 plus 2, which is 1. So combine like terms, simplify, so it's 7 over 1, which is just 7. So you could say f of -1 equals 7. Then let's do it again with the 3. Okay, and then 3 plus 2. And you don't have to have the stuff on the bottom in parentheses. It's mostly beneficial when you're doing multiplication, like the stuff on the top. Multiplication or exponents, that's where the exponents actually make the most difference. Otherwise, if you're adding and subtracting stuff like this, the parentheses don't really make much of a difference. So 3 squared, 9. 6 times 3, so that's 9 minus 18 over 3 plus 2 is 5. So 9 minus 18, that's a -9 over 5. So that is it right there. You can't reduce it. I don't want it as decimals. Remember, must be fractions, improper fractions. Okay? I want them in improper fractions. Alright? I'm sorry, I kind of ran off the page over there. Alright, so same thing with C and D, just plug them in. So let's check out page 2. Alright, so which equation is linear? Explain how you know below. So remember, linear functions look like this. Y equals mx plus b. Anything else is not linear. Or I guess if you can rearrange it to mx plus b. So we have this, we got standard form, and we got point slope form. Okay, so anytime you're looking for something that's linear form, you do not want squares. Okay, so that is out. C is out because of that x squared. D is out because of that y squared. And we're looking over here at A and B. So we have x times y equals 60. Well, in mx plus b over here, y and x are not multiplied together, and you cannot rearrange it to look like A. So that means the only one that's left is B. And your explanation is because you can rearrange it to y equals mx plus b. Rearrange it to y equals mx plus b. You can make it look like that. Okay? So using the same information for number 7, you're looking for things that look like y equals mx plus b. Instead here it's going to be a S or an F from R or something. Any one of these. So here you got a variable in the denominator. Can't do it. Okay? That's not linear. Here, square root, radical. Can't do it. Here is a cube, so that is out also. So that means the only thing you got left is h, because that can be written as y equals mx plus b, or in the form. Okay? So number 8, we had types of symmetry. All right. So we had either line symmetry or we had point symmetry. So remember line symmetry, that'd be this example, is where you can pretty much cut it in half. So I can cut it in half and reflect one side onto the other side, okay, which is this one. All parabolas are going to have that. And then you would say that this is the line x equals 2 because it only touches the x-axis at 2. This is the only axis that it runs into, so it's an x equals line. Okay, and remember I said another thing, line symmetry is only going to be vertical lines. So all vertical lines are x equals something. Okay, and then point symmetry is just going to be an ordered pair. So this is line at x equals 2. This one right here, remember those are like fan blades. Point symmetry at 0, 2. Okay, so pretty quick. Alrighty, these ones down here, for the following graph, state end behaviors. Alright, so remember end behaviors, I told you guys that you always needed to start end behaviors like this. So x approaches negative infinity, x approaches positive infinity. And then what is f of x going to do, or what is your function going to do? If you can remember this right here, that's 90% of it. Because this means as I go to the left, this means as I go to the right. So I'm going to write that over here too, because it's going to be exactly the same. Okay, or correct positive infinity. So then we just ask ourselves, as we go to the left, what's my function doing? So I'm looking at my function, following it to the left, going down. Okay, it's going down towards negative infinity. So as I go to the right, what's my function doing? So I'm going to the right here, I'm going up towards positive infinity. That's my end behavior. We look on these, they're both going up. Okay, so this is both positive infinity for this one. Then we want to estimate any relative maximum or minimum. Alright, so maximums and minimums, those are just high points or low points. So I'm just going to highlight those on here. So that's one of them, that's one of them, that's one of them. And then over here, all these areas that I circled, those are maxes or mins. Okay, so here, thinking it's going up, it's a high point, that is a maximum. So we can kind of estimate that. That's why it says estimate any relative maximums or minimums. We can use decimals here. So it'd be about 6.5. So max 6.5 will be 0, 6.5. Because we're not going left and right any. So fix that. 0, 6.5. And then minimum, that guy right there. So 2, about 2.5. And then let's do the same thing over here. So we'll say that one, we'll do maximums first because I did that on the first one. So max of 1, let's say about 4.5. And then minimum, we got 2 of them, so I'm just going to put them on the same line here. So I have -1, -3.5. And then I have, let's say, about 2 1/3, or you can say 2.5. I'll just do a nice number, so 2.5, and then we're up at 1.5. Okay, so that's good enough. Estimate. You can estimate to the nearest half or nearest quarter, as long as you're in the ballpark. Okay, and then the last part here said estimate any zeros of the function. So zeros are where they cross the axis. So we have 1 0 here. So my 0, label it with a big Z, is negative, we'll say 1.25. 1.25, 0. And then my zeros here, we'll say this one's about 1.1. Okay. So negative 1.10, and then we have another one there. It's the origin, so that's 0, 0. Okay, so these ones are going to be worth a lot of points because there's a lot of information. You have to look just like that when you put your information in there. So remember, you have to do that end behavior notation just like that. So as you go to the left, what happens? As you go to the right, what happens? Okay, so remember these. Okay, on to the next page. So this one I'm going to kind of zoom through a little bit because I've done this in class quite a bit. So parent functions. Okay, my parent function for, let's do this one first. So they all start at 0, 0. Okay, so you could label 0, 0 on all these. X squared is a parabola. So you could do an XY chart if you wanted to. Remember, for parabolas, you want to do an XY chart with 2 points. So if I did that, it'd be like this, X, Y. I pick 1, 2, because I want 2 points on the same side. So I'd get 1, 1, and 2, 4. If I did that right there. So that's your parent function. Absolute values, remember something like this, starts at 0, 0. I have a slope of 1, so I go up 1 over 1 in both directions. And then the last one, y equals x, that's just a parent function for a line. That's just a straight diagonal line through the origin. Okay. So on to number 11. Like I said before I started going through this, I'm not going to have you guys, you don't have to memorize that. I'm going to give it to you on the board or write it on the test. But your general forms for parabolas, we'll do parabolas first. So it's f of x equals ax minus h squared plus k. And then absolute values, f of x equals a absolute value x minus h plus k. So I'm just going to fill out one of these because a, h, and k do the same thing. I guess I could do a little bit more information over here. But a is going to be your dilation factor. Okay, a controls dilation, could be, and here it's just vertical. That's all I'm going to give you. I'm not going to try to trick you guys with the horizontal stuff. Okay, a is dilation over here also. But remember, when you're graphing these, that is also slope of your lines or your absolute value function. Okay, and then h, that controls your shifting left and right because that's in with the x. X values go left and right. So that's translate left and right. Same thing here, and then this one is translate vertically. Same thing there. So really, these general forms are pretty much the same. Parabolas are just going to have the parentheses with the squared, and absolute values are going to have the straight lines there, the straight brackets. The only extra thing, it's kind of nice with absolute values because that a is your slope. Okay, that's going to help you graph it easier. These guys right here, you have to make the XY chart. Okay, and it's a pretty quick XY chart. So I'll just do a couple of these down here and I'll give you some info on that one. So if I'm looking at this, I'm trying to figure out what transformation is going on. So I can compare this to this one up here. Okay, I can compare that to my general form up above. So my A is just a 1, it's not doing anything. My H right there, it's a +1 inside of here. So remember I said think opposite. So if you're thinking opposite, that's going to shift it left 1. And then I have nothing out here, so +0. So it's not going to shift up or down. So really I have my vertex, my starting point right there at -1, 0. And then to do my XY chart, okay, I just need 2 points. I want 2 points on the right hand side, so I do a 0 and a 1. So if I plug in a 0, it's the 0 plus 1 squared, that's just a 1. Put in a 1, 1 plus 1, that's 2, squared, that's 4. So I have 0, 1, 1, 4. Same thing on this side, because I can reflect those, I can mirror those points. And then draw my parabola. Okay, and then explain my transformation. This would be translation or translate left 1 unit. Okay, so that's what I'm going to be looking for on these. I'm going to be looking for, if it's a parabola, I'm going to be looking for a little XY chart there, then your graph with your points, okay, and then a little info here about what transformation. Okay, another thing I forgot to mention up here above, if I have a negative, remember if I had a negative out front, so say I put a negative out there, that's going to take it and that's going to reflect it over the x. So it would look like that if I had a negative out front. Okay, so this would be a reflection. All those notes that we took for that are very beneficial. Okay, it's going to go through all the stuff that you need. Alright, so this one right here, this is the absolute value function. You don't need an XY chart for that. You just look at your function and you compare it to this information up above and you say what's going on. So right there, I have nothing inside with the X. So my H is a 0. I have the -2 on the outside with the Y, or for the Y. So think same as the stuff on the outside. So that's going to translate my function from 0, 0 to 0, -2. And then if we look out front, your slope is a 1. So that means I'm just going up 1 over 1, up 1 over 1. And that is our absolute value function. And then it would be translate down 2 units. Okay, if you see something like this one right here, there is no H and there is no K, so that one would start at 0, 0, and then you would just do an XY chart with points on the right hand side. Okay? These ones down here, this is the stuff that we did on Thursday, so you're just looking at that and trying to figure out what's happening to the functions. So this right here, the first one, f of x plus 2, think of what f of x is the same as. That's the same as y. So if I do y plus 2, I'm adding 2 to all my y units, or that's going to be a vertical translation. Okay? So vertically translate up 2. This one right here. So that's the one I just talked about a little bit ago. If you have a negative out in front of everything, that's a reflection. So this is reflect over x-axis. Last one here, this one's a little bit harder. Okay, so remember, if I have the negative out in front, that reflects over the x. If I switch it to the inside, that reflects over the y-axis. So it's going to reflect over the y and translate up 3. So vertical translate up 3. Okay. I'll do one piecewise. You don't have to worry about step functions here. So remember, these are the step functions. You don't have to worry about those. It might be a bonus question, so make sure you look it up if you want some bonus. Otherwise, don't worry about it. This one down here is another absolute value, so it'll be 13D. That's just like what we did on the last page, so I'm not going to do that one. Okay, I'm going to do one of the piecewise functions and then explain domain and range. Okay, so looking at this piecewise function, I need to graph f of x equals -1, f of x equals 2x, and f of x equals 6. There's 3 functions in one, but we just want the pieces. Okay, so graphing f of x equals -1. That's a y equals -1. And I want everything less than or equal to 0. So -1 would be down here, right? And I want everything to the left of 0. So graphing mode, my line would be right here. Then I switch to number line mode. X is less than or equal to 0, so that means I'd have here to the left. So I want here, and I'm going to the left, because that's the part of the line that we want. And then this one, 2x, so we're going from 0 to 3. Remember when you see something like this right here, when you see something like that, that's the 2 values you're going in between. So I'm going from 0 to 3. I'm going to have an open circle on the left and a closed circle on the right. So 2x would start at 0, 0, and go up 2 over 1, up 2 over 1, up 2 over 1, like that. Okay, and I would keep going on forever, but I only want from 0 to 3. So if I'm switching to number line mode, from 0 to 3, right there. So open circle at 0, filled in circle at 3, connect the dots. And then my last one right here, so y equals, or f of x equals 6. So 1, 2, 3, 4, 5, 6. Straight line here at 6. But I only want greater than 3. So I want numbers right of 3. So if I'm thinking of number line mode, so graphing mode up here, number line mode, I find 3. So 3 and over would be like that. And I don't really need to worry about that right there because my dot's already filled in from the one up above. So that's what the graph looks like. So we need to find domain and range of this guy. Domain, remember, we scan from left to right, and you try to see if there's any gaps. I always stopped right here and I said, all right, see if they line up. If they do, see if there's a filled in circle. So I have a filled in circle on the bottom, so that means I have everything, all real numbers for my domain. My range, we're doing the same thing except we're going from bottom to top. So there are gaps on this one, so I can see that this is the first piece I run into, and then there's a gap. So I need to make a range for this piece and then make a range for this piece up here. So this, think where's the line stuck at? It's just right here. So that's y equals -1. That takes care of this line. And then we need to go from here to here. It's not going beyond there. It's just stuck from here to here. So remember, it's going to look just like this where it's between two numbers, except there's a y. So 0 on the left-hand side, filled in. I'm going up to 6. And it is, or it's not filled in down here, it is filled in up there. So I'm going from 0 to 6 on the y. So 0 up to 6. That's going to be the values I cover. Alright? So that's the piecewise function. There will be 1 or 2 of those on the test. Okay, so make sure that you try to watch videos, even more videos, if you don't understand how to do it. Okay? Domain and range for something like this. I'm going to go back to a different example and use that one. So if I had this right here, okay, doing the domain and range for this one, my domain, look at these arrows going to the left and to the right. This covers everything. So your domain would be all real numbers. Your range, you look for that bottom point and that top point. So if I'm looking up or down, okay, I see this bottom point right there, and I'm going up from there. So it's y is greater than or equal to 2. Okay? So, almost there, almost done. Graphing 14, I'm not going to go over those. All you got to do is graph them. You're looking for where they cross the x-axis, where they cross the y-axis. Okay, same thing for both of those. So you guys should be able to graph those and see where they cross the axis. Alright, 15 is the one that's kind of worded interesting. Okay, so it says find the zeros of the function by graphing and then solving. So, graphing f of x equals 2/3 x plus 4. Start at 4, and I go up 2 over 3. So I'd be over here, I go down 2 over 3, down 2 over 3. So I kind of run off my graph. That's okay. Looks like that. So I would cross my x-axis at 1, 2, 3, 4, 5, 6. So by graphing I see x equals -6. And then it says write the related equation and solve. So where it says that, I change the f of x into a 0 and then solve. So it's like this. Okay, so I changed the f of x to a 0 because I want to see where the y value is 0, which is your x-intercept. Okay, so subtract 4, I get -4 equals 2/3 x. So how do I solve something like this from here? You can say divide by 2/3, or the better way, multiply by its reciprocal. So that cancels out here, and then I have 3/2 times 4. So cross cancel, 2 and 4 cross cancel, so 3 times -2, so x equals -6. Got it. Okay, we're going to finish up with the matrices. It's out a while ago. Make sure you guys know how to do it. If you have something like 16, okay, remember you have to do that scalar multiplication first. So that 3 goes into everything. So then I can rewrite it like so. Plus, after I multiply everything by that 3. Alright, so once you do that, then you can just add it from left to right. So 1 plus a negative 3, that gets me a negative 2. 6 plus a negative 3, that gets me to a 3. Negative 4 and 9, that gets me to a 5. And 2 and 12 gets me to a 14. So that is our resultant matrix. Okay, I'm only going to do one of the multiplication problems. Remember, when you're multiplying matrices, you have to check the size, and if the inside numbers line up, then you can actually multiply it. The outside numbers tell you what the size of your new matrix is going to be. So I'm going to have a 2 by 3 when I'm done. Okay, so then we take multiplication is the same way as you read the size, so it's rows times columns. So 3 times 2, that's 6, and you add here. So 6 plus 2, and then we do the next one, so 0 plus a negative 8, and then 12 plus a negative 6. That's my first row. Then I bounce down to the second row in this little one, so I multiply, that's 4 plus negative 4, and then 0 plus 16, and 8 plus 12. So my new matrix is going to be a 2 rows by 3 columns. Okay, so it's 8, and then a negative 8, and then a 6, 0, 16, 20. That is your new matrix. And I think I didn't make any errors on that one. If I did make errors in the video, then compare it with the answer key that I sent you guys. I'm trying to do this, get it done quick so you guys have something to look at. Okay, then the last couple down here, we want to find the inverse of a matrix. So finding the inverse, remember, we have to find the determinant, and then we take the determinant and we divide that through the adjugate matrix. So you guys should remember me saying that stuff. So determinant, I cross multiply and you subtract. So it's 3 minus a negative 8, so my determinant is, boom, boom, 11. So my adjugates, where I flip these around, so it'll be 1, a 3, and then I change the sign of these two. So it's negative 4, positive 2. That's my adjugate matrix, and I take all of them and I divide them by the 11, or 1/11 times them. Okay. Remember I said it was easier just to divide everything by that determinant. So my inverse matrix will be 1/11, 2/11, negative 4/11, and 3/11. That is your inverse. Okay. Last one. I'm going to do this with inverse matrices because that was the harder one. Everybody couldn't kind of seem to have a handle on Cramer's rule. Remember, with Cramer's, you have to make a constant matrix, then you make an X matrix and a Y matrix, find the determinants of all 3 of them, and then you divide by the determinant of the constant matrix. But with inverse matrices, the way I'm going to do it, remember we need to make that constant matrix again, just like in Cramer's rule. So that's the numbers out in front of the variables. And then we make a variable matrix like that. And then we make a solution matrix. Okay. I think I said constant. I meant coefficient matrix here. This is the constant matrix. So I need to find the inverse of this guy. So find the determinant. So that's 14. So determinant of A equals 14 minus 12, so that is a 2. So then I take my adjugate matrix and I divide everything by 2. So it'd be 7 switches to here, so it's 7 over 2. And then down here is going to be 2 over 2, which is a 1. And then up here we change the signs, so that's negative 3 over 2. And then this one is negative 4 over 2, so that's negative 2. That's your inverse matrix. And then you take that inverse matrix and then you're going to multiply it by your constant matrix. So the multiplication here is, the hard part is the fraction. That's actually quicker than multiplying with the one that we did before. Okay, but remember to take rows and columns. So row times column. So 7/2 times the negative 2. that is a -7, and then -3/2 times a -6, that is a positive. So 2 and the 6 would cross cancel, that turn into a 3, so it gives me a +9. And then same thing down here. So -2 times -2, that's 4. 1 times 6, or -6, so that's the -6. So we get a 2 up there, a -2 down there. That's your solution. So it would be 2, -2. All right, so that would be the solution. And remember, I can check my answer here to make sure that I did it right with these inverse matrices, because if I plug these into everything, if I plug these back into my original functions, then it will actually work out. So you can check to see if you did it right with this or with Cramer's rule. It'll work either way. Okay, so you can check that. So that is the conclusion of the study guide. If you got any other questions tonight, let me know. Okay, wanted to spend some time making this video for you guys. If I made some errors, I'm sorry. I think I felt pretty confident about what I was doing on here. So if you would like 2 extra bonus points, then you can send me an email saying that you watched the video. Okay, so it'll be the 2 fix-it points that you get from this review guide for doing this, which I pretty much did it for you, and then you can get 2 more points by sending me an email saying that you watched the video. Okay, so if you got any other questions, let me know. Otherwise, good luck tomorrow. Hope you guys had a good weekend.